Section 5.5, Problems with the Quotient Rule, numbers 7, 12, and 14. The quotient rule tells us that if we have two terms being divided and they're like bases, then we can go ahead and subtract the exponents. And let's take a look at why that's true. If you look at this problem here, we have x to the fifth over x cubed. Well, if we expand this to be no exponents, so we have 5 x's being multiplied, and then the x cubed expands to x times x times x, then you'll notice that 3 x's on the bottom can cancel with 3 on top, and we're left with 2 x's, or x squared. And that's why it's okay to use the shortcut and just say x to the fifth over x cubed equals x to the 5 minus 3, or x squared. Alright, so when you're dividing same bases, you can always subtract the exponents, and just keep in mind that you're always doing the top exponent subtract the bottom exponent. So when we have number 7, 5 to the fourth over 5 to the 7, what we're going to do is keep the base and do 4 minus 7. That gives us 5 to the minus 3. In final answers, with any kind of exponent problems, you never want to leave a negative exponent for the final answer. So we need to now shift this, think of it as over 1, shift it down because it has a negative exponent. 1 over 5 cubed. And that would be 1 over 125. Number 12, m to the 7 over m to the minus 8. So we just go right to applying the quotient rule. Keep the base, 7 minus a minus 8. And watch there that we have two negatives happening. We're subtracting a negative number. Subtracting a negative means add the opposite. So what we end up getting is m to the 15. And number 14, y to the 6 over 3y to the 4th. Let's take care of the numbers first. 3 divides into 21, leaving us a 7. And then we can apply the exponent rule for the variables. So that gives us 7y to the 6 minus 4, or 7y squared. So remember, all exponent rules are exactly the same for positive and negative exponents. And in a final answer, don't leave a negative exponent, always shift to make it a positive.